The team at Kickboxer is working on their latest motorcycle build, the KB2, a powerful street bike that uses a popular 4-cylinder turbocharged boxer engine normally found in an automobile. Debbie, Eric, and Dawn are under pressure to finish the design and meet an important deadline with their manufacturer. They'll need the powerful design and validation tools in 3DEXPERIENCE SOLIDWORKS Premium, taking advantage of the cloud to keep their data current. And with everyone working remote, they'll need to work concurrently if they stand any chance of getting their last-minute changes in place. Debbie's the lead designer at Kickboxer, and she's responsible for the look and feel of the bike. She's just finished modeling the tank in X-Shape, a subdivisional modeler on the 3DEXPERIENCE platform, and has added some final details in SOLIDWORKS. Since this motorcycle will have a ton of power, she's going to add some tank knee pads so the rider can have a bit more grip while cornering. First, Debbie reserves this part so she alone can make edits, while Eric and Dawn can work on other areas of the design concurrently, without stepping on each other's toes in the process. Debbie creates a surface to represent the shape and location of the knee pad. But she needs to understand how the pad will stretch or compress when applied. Usually, tank knee pads are applied like a sticker, but on this highly curved surface, there's a chance it can end up with unsightly ripples. By using Surface Flatten, she ensures it'll go on smooth without any ripples or air bubbles. She unreserves the tank and saves her changes to the cloud. While Debbie is designing the tank in X-Shape, Eric the engineer tackles some important suspension issues with the front end of the motorcycle. Instead of a traditional fixed fork and suspension, the KB2 uses an innovative swing arm and cable-driven steering system. This adds a ton of complexity to the front end design, so Eric created a virtual testing rig to understand how the front end will perform while riding over large bumps and steering the bike. To simulate the physics of this rigorous test, Eric creates a motion analysis. He uses a virtual motor to turn the testing drum, which will simulate 40 miles per hour. Now, he adds an oscillating motor to actuate the steering system moving through the entire steering radius. Finally, he defines a virtual spring and damper and runs the analysis. By plotting the vertical displacement, velocity, and acceleration, Eric can try out multiple spring damper combinations as he searches for the perfect balance of comfort and performance. Dawn's primary job is fitting this huge motor into the KB2's confined chassis. The original starter for the engine was way too big, so Dawn found a smaller profile starter as a replacement, and begins to mate the starter into place when he receives a message from Debbie asking if he could run some wires from the new starter to the starter relay. Quick on the job, Dawn searches for an appropriate wire terminal in Kickboxer's cloud-shared library of commonly used parts, and simply drags and snaps the terminals into place. He'll take a moment to recolor the terminals to match the red accents of the bike, and finishes the job by creating the wire routes. Meanwhile, Eric discovered the right spring and damper combination for the front end, and turns his attention to understanding whether the complex steering linkage will be strong enough to handle extreme riding conditions. He creates a simple plot to give him the calculated reaction forces on the tie rod end through the entire testing cycle. Eric will use the maximum force to run a stress test on the assembly. Eric wants to make sure he's working from the latest and greatest CAD model. He sees all green check marks, which lets him know everything is current and he can move on with the stress analysis. He adds boundary conditions to simulate how the steering linkage assembles to the frame, and uses virtual pins to simulate the joint locations. After adding the maximum load to the tie rod end, he runs the analysis and views the results. He can quickly see that the system passes the factor of safety test, and then checks the maximum displacement just in case. It appears the torsion rod is twisting so much, it could affect the rider's ability to control steering. He changes the material of the torsion rod to something a little stiffer and reruns the analysis. With one simple change, he's reduced the total displacement by nearly 25% and now feels comfortable with the steering system's performance. To complete the task, he saves to the cloud so the design can be shared with the manufacturer. By working concurrently, Debbie, Eric, and Dawn were able to meet their deadlines in record time. Whether it was organic shape design, flattening complex surfaces, rigid body motion, wire routing, or virtual stress testing, 3DEXPERIENCE SOLIDWORKS Premium helped them tackle their design challenges while using the cloud to keep their data current. To learn more, contact your SOLIDWORKS reseller today.